All right, it looks like we are live. Yes, it's working. Excellent. Just gotta double check, make sure this is working. Excellent. Okay, we are good to go. Sorry about all the trouble. I was just getting things set up. Got my microphone set up. Let me know if it's sounding all right. I'll put the chat in this other window here. Pop out the chat. There we go. Sorry about the wait, guys. So what I was working on was getting this camera over here. I'll show you. This camera over here set up, and also, if I can turn it enough, you can see I built this little microphone piece right down here that hooks up onto my desk. So it took me a little while to find the jigsaw blades and get it all happening. Sorry about that. And yeah, we got some new cameras, and hopefully they'll work out. My front camera seems to be not so high quality right now, so I'm not sure what that's all about. I think it doesn't do very well in low light. That's probably the issue. This camera seems to have a focus, so we can get real close to things, I think. Get right in close and get some good camera angles with this guy. So that's awesome. And then I have a life cam that's operating this camera over here. And I've had that one for a while. I used to think that it was busted, but turns out I had it hooked up to a USB hub, I think, and it didn't get enough power. So yeah, so the camera I just got, it actually, I don't think it has a name. It's just called HD camera from Amazon, and it's pretty decent. It's 1080p, so it has pretty decent quality. It looks sharp. I like the quality from it. It was a $30 camera, so yeah, Amazon is finally selling webcams again. I know that there was a few places that ran out of webcams. Because there was such a high demand to go on to remote things such as Zoom. Oh yes, PDP. No, I'm not really stuck with the snow. We just ran into a possible exposure to COVID, and so I decided to stay home while I figured it out and figured out how exposed I was and that kind of thing. Turns out I didn't have contact with that person, but I was in the same building as them. Well, closer than that, I guess. The same room as them. But yeah, it's all good. So, crisis averted. So now I'm streaming from the lair, my garage. It's changed a little bit since I was doing this last. Yes, again. Yeah, it's like the third COVID scare that I've been involved in, which is pretty sad. It happens though. It's the world we live in. So the garage has changed. There's no shelf directly behind me any longer. I changed that up, and now it's pretty open. I made myself a movable workbench, I guess you'd call it. Yeah, I'll quickly show it off for you for a quick sec here. This is it. So it's on casters. There must be a weird smudge on my lens there. Couldn't see my face. Give me a quick second to clean that up. that's a little better. It might be just because of this light up here. Anyways, turns out that I had pretty much everything I needed to build this workbench, minus a couple of pieces of wood that my buddy James gave me. A couple 2x6s and some 2x4s. So yeah, I just needed those to finish it off. I had the top in my in my shed. Had a whole bunch of like good wood. Actually, the same wood as this recycled workbench top. They're just the sides of shelves, basically. And they work out nicely for bench tops. And then I bought myself a set of casters. I think they're $300 a piece. Not $300, but 300 pounds of, I guess, load force that they can take, each one of them. So, and they're only $30 for a set of 4. Another Amazon buy. So yeah, I should stop talking about the garage and get on to what we're doing today for the hack. So I have this separate laptop over here because I need to install Tightvnc on it, and then I need to remote into this guy over here, which is the AtomicPi, which is the computer that we're putting into the Treat-o-matic to make it automatically dispense candy with a couple of different triggers. We're going to use, I think, mostly speech recognition, and then we'll also depend on a passive infrared sensor and a camera. So I actually did some work with the PIR sensor this week and tested it out. It works pretty good. Grab it here. Here it is. I'm not sure what this type is called. See how well this focuses. I don't remember the actual part number for this guy. Pretty common though. It's got these 2 potentiometers. One of them adjusts the distance that it will detect to. And man, I turned it all the way down and it could still detect me at, I think, 15 or 20 feet. So that was surprising. And the other one is the delay time. So how long until the next trigger, I guess you could call it, or the next event of detecting a person. So, and that will go from, I think it's 0.3 seconds, so 300 milliseconds, until it refreshes and tries to look for a person again, to up to 5 minutes. So I was turning an LED on and off with it and just adjusting it a little bit. And yeah, just a fine adjustment on that potentiometer will make it so that somebody it'll like trigger for quite a long time actually. So I was surprised that, you know, when you trigger for like a few milliseconds, it's fine, but you start turning it up a bit and then you're like, oh man, when's this LED turning off? It's been triggered for quite a long time. And this guy takes 5 volts, so it's perfect. It works out well with the system that we're creating, that everything is running off of 5. So yeah, this is definitely a big passive infrared sensor. I should show you some other ones that I have. So you think that's big? I got some bigger ones. So these are from the security industry. This guy here. And it actually takes, I think it's 2 or 3 Panasonic 3-volt batteries. It's an interesting size of battery, that's for sure. So you gotta pop that off. Yeah, there we go. It takes 3 of them. So these are meant to last a while and not have to be changed in some time. So that's why they take such big batteries. And lots of these passive infrared sensors need a higher voltage. So I have one here, actually, I think it requires 12 volts. I believe it's this one. I think this is one from SparkFun, possibly. And then I have these little guys too, little tiny passive infrared sensors, PIR sensors. So you can get them in small or pretty big. And then I have a really old one here too that sounds an alarm. It has like a buzzer right there. So enough of that. Don't need to be wasting any more time on that. Just figured I'd show you guys the range of PIRs. Might as well bring this guy over. We don't need him yet, but we will soon. So after we get the Tightvnc working, we're going to be able to remote into the AtomicPi and hook everything up and screw it all together and not have to worry about ever having to like hook HDMI to it and that kind of thing, because right now that's how we're doing it over here. Our HDMI connector is right there plugged into the board. So we don't want to have a monitor hooked up to this thing. We just want it to work on its own, and if I have to, I'll just tap into it with a VNC or remote in program. And so the reason why I have to do Tightvnc is this AtomicPi we installed with Windows 10 Home Edition, and I guess the Home Edition is it doesn't have the feature of remote desktop. It doesn't allow you to have it. It has to be Pro, I guess, in order to have that. I didn't even know that until today. The things you figure out, I guess, along the way. Tonight we are listening to the copyright-free playlist again that I created. I'm starting to whittle it down, try to get, the best copyright-free songs I can find and throw them on there. And it's going all right. It's mostly chill step, dubstep, EDM. Yeah, just random copyright-free stuff. All right, so on the desktop over here, I won't be able to show you the screen. I won't be able to flip it over for you, but hopefully this camera will be able to show you enough. We can probably pull it in a little bit closer. Okay, so, and let me know if this microphone is working or not. It's working well, I should say. I guess, yeah, I'm guessing you can hear me because we've been chatting back and forth on the on the chat window. So, but let me know if the sound level is good. All right, let's install Tightvnc. Now that is a weird font. I don't know if you can see that, but see if I can get in closer. I thought it was actually a different language than English, but nope. It's just a weird font that they have for their license agreement here. Typical is fine. VNC files with associate the VNC files with Tightvnc viewer, yes. Register server as a system, I guess so. Alright, so I don't have much experience with Tightvnc, so we'll see how this goes. It says, please protect your Tightvnc service. Be sure to enter a password. Password from remote access. Yeah, I don't know. Something easy. Administrative password. I don't need that. Okay, so that's good. Let's run it. Okay, it says enter an IP address. Alright, so we're going to have to go over to our other computer. So let me switch the views here. Alright, let's go over here. This is our AtomicPi. And we're going to check out the IP address. And you know what? I don't really know a fast way to do it, but this is the usual way I do it. I run the command prompt. Try to get it in your view here. And then I run ipconfig. I think I'll try to make this a static IP once I'm ready. Well, looks like I missed the I. ipconfig. Okay. And it looks like we're at 192.168.0.13. Okay, so we are on the same network here. So I should be able to just go over to this other guy here. Just figuring out which view I want here. Yeah, I think I want this one. Okay, so 192. Oops, 13. Okay, here we go. All right, password is 12345. Oh, authentication failed from this guy. So I think I might know why. Oops, didn't mean to close that down. Because I wasn't running Tightvnc on this side. So let's run it. So let's go options. And it might be because I have different passwords set up. It's a little bit hard to read on that screen, that's for sure. Licensing mode. I don't actually know where I can change the password. Let's have a quick look over here. Options. Okay, and maybe I have to have the IP address on this guy in the other one. Let's see here. Run command prompt. So I'm 10 on this computer. Okay. Sorry, I have like 3 different mouses, 3 different keyboards going on here. Okay. We'll see what happens when we connect now. We'll try from this side. There we go. I don't think I had the right password because I have I don't remember the password that I set up on this guy actually. So right now I'm VNC'd from the AtomicPi into this computer. That's not what I want. So maybe what I'll do is I'll uninstall VNC because I can't see where to full screen. Just looking at the options here. I wonder if there's a disconnect button. Pause. Okay. Let's just add remove programs. Oh, the sad part is that I have to download Tightvnc again. There's got to be a way. Oops. Did I just minimize it or did I X out of it? That's kind of weird. Maybe it goes into the system tray, I think, instead of being minimized. So maybe configure yeah, very weird. I don't know why. Do not know why it's doing that. So here we go. We're going to uninstall Tightvnc on the AtomicPi, reinstall it, put the same password on there so that I won't forget. It'll probably take me a second to download it as well. So today, hopefully, once we get this VNC stuff working, then we can put it all together, start testing it all out as one complete system. I also had to delete a whole bunch of stuff on the AtomicPi to free up some space on it. It was running out of space. And then I had forgotten to put it into metered mode so that it wouldn't download Windows updates. So that's a nice thing. Like, there isn't really a, what would you call it? Like, I don't think there's a setting in Windows at all to turn off Windows Update. Like, it always wants to do something. Always wants to do it. Oh, that downloaded like lightning fast. Except if you turn on metered mode. So metered mode will allow you to basically bypass Windows Update. It'll just not do it because if you're on a metered connection, it means that you're paying for your connection. So you're basically, if you're like using your cell network as an internet connection. So turn on metering and it solves everything. Okay, so do not use the password. And then I'll require this kind of password. Okay, so I wonder, do I have to be running Tightvnc in order for me to get into this? Let's have a look here. 2, 3, 4, 5. Okay. No, I do not. Sweet! It's working. It's working. The background didn't show up. That's kind of a weird thing. But who cares? We don't need that. We do need to be able to see ARC. Or let's full screen this. Exit full screen, Control-Alt-Shift-F. Okay, sure. Oh, weird. Yeah, it doesn't show the toolbar down here. Oh, there we go. I have to scroll down. That's funny. Okay. We'll load up ARC here. See how that goes. I think it's because they're different aspect ratios. That's the why it gets a little weird. Here we go. So I'm guessing there's going to be some lag because I'm VNCing in here. We'll open up the project we've been using. It's definitely taking a little while. There it is, my misspelled project. I think I was supposed to write audio test and turned into some other weird, like, Audi test. Okay, so let's try playing something. Aha! It won't play something because we don't have the audio amplifier hooked up to it. It's one of the things we got to do. Okay, so right on, that's working. So we will shut this down. We will put everything back together. We'll put in the audio amplifier, the USB audio amplifier. We'll put in, we have the Arduino in there already. What else has to go in there? The camera. Yes, the camera will need to go in there as well. And then, yeah, we should be able to remote in, do our thing. I don't think that everything will be in real time. It won't be too fast because I'm remoting in, but once everything's configured, it should run fast when we're not remoting in, I'm guessing. Okay, so let's shut this down and put everything together. Shut down anyway. So we will have to find a way to mount the PIR sensor, this guy, somewhere onto the frame of that machine. And then we'll have to find a spot for the camera as well. The nice thing about the PIR sensor is actually it's just a digital sensor. Delivers a low when it doesn't see anybody and a high when it does, and then your obviously your potentiometers adjust the distance and the delay time. Oh yeah, last time I shut down the AtomicPi, it took forever to shut down, so we'll see how that goes. In the meantime, we'll get the main chassis ready. We also have to drill a hole in it, I forgot, because we need to put power plugged into the front. Oh yes, and I was going to create, let me adjust this camera here. Sorry you get to see everything. Oh yeah, there's a new laser cutter that we got a few weeks ago. We got a Muse laser cutter. So now I can do some more cool hardware things with it, like create a bezel for this guy. Oh yes, you know what? We're gonna run out of USB ports. I forgot about this guy. This guy's USB as well. So, you know what? We may get away without using a camera. We'll see. We'll see. And the PIR sensor is going to have to be on the front somewhere around here. I don't know if I want to drill a big hole right there or mount this somewhere else. Maybe right here. Yeah, there is some plastic supports in both of those places. We could offset it, put it over maybe on this side. This is more central to the whole entire unit, so we could go over like right there. Dremel a big hole or something in there. It's gonna look ugly. We'll see. So we have to hook up all of our servo connections and our limit switch connections to all the places they need to go. And I don't know if I'll have enough digital I/O. We'll have to see. For some reason, D12 wasn't working. I'll have to check in on that. Last time when I was trying to run a servo off a D12, it was not responding. So I'll have to look at the Arduino underneath and see what's what, because we may need that port. If that's the case, I'm going to probably have to remove the hot glue that's on there and then re-hot glue it back on. So while we wait for things to shut down, let us warm up a hot glue gun. I'm not sure if you remember last week I was telling you about the wireless hot glue gun that Walmart has. Where does it say it? Oh, it doesn't say it here, I guess, but it did say on the package. But this is what they mean by wireless. You can unplug it. It's too funny. So you can unplug it from the wall, from right here, and go and use it until it cools down again, and you got to plug it back in. Too funny. Yeah, so I do plan to put the PIR in the robot. The camera I'm not sure about now because I'm running out of USB ports. This isn't good. Because I have the Arduino using one. I have only 3 USB ports at the moment. Oh, yes, wait. You remind me of something. I'm not using a USB port that I forgot about. Because there is an extra non-USB plug USB port right there beside the USB connector. If I move this wire, you can probably see it better. This guy here is a 5-pin JST XH style, I think, plug. So I'd have to look in my collection and see if I have that type of plug. And then we can make, I think I have enough parts to make like a little custom adapter for that. So I wouldn't want to like modify the actual camera's cord itself. That would be a pain. So let's have a look for that too while I'm going to plug in the hot glue gun, throw it on the workbench back there, and let that heat up. got to some slow music, so let's move it over to some chiptune-ish music. This was what I was looking for. A USB A male to female. We just need the female side. So we're gonna cut that off and put on one of these connectors if we can find one. We'll do some digging and see if we can find that. And also we need to find the wiring diagram for that, because I don't know what is what. So let's go do some browsing actually. So I'll take you with me in a second here. Still don't know why it's AtomicPi is just taking forever to shut down. Okay. Let's go on a journey. I think I have the AtomicPi linked here. Yep, I do. Now let's see. Board specifications, data sheet, processor I/O schematics. We'll see if we can find it here. So we have, yes, the power button. We have that soldered to an actual small power button. Oh yes, let's look. See if we can do just a Control F webcam. Cause that, yeah, it seems to be. It seems it found something. Webcam and fan. Okay, good. Up. Okay, webcam and fan. Where is the 5-pin connector? Here we go. Perfect. This is it. Okay, so we have 1 and 5 are connected to ground. Our hot wire is 2. And D plus, D minus is 3 and 4. So let's just make sure our orientation is good. Hey Will, welcome man. I'm just looking at the AtomicPi here. We're mapping out there's that USB connector right beside the USB 3 connector, which is labeled webcam. I'm just looking at the pinout of it because it's not a standard USB port. It's just a JST connector. So we found the wiring for it. Beauty. Now I just want to check the orientation and see which side is pin 1 and which side is... You know what? I'll just use a multimeter, and it should give me the 5 volts on that on the one side. Doesn't matter which side I use for ground because both outside pins are ground. Okay, so let me switch the view so you guys can see what I'm doing here. Okay. So you can see the readout of the multimeter there, barely. It's time to go on a search. Oh. It looks like OBS disconnected for a little bit there. Very weird. And finally, the AtomicPi shut down after 1 million minutes. All right. Let me search here for a second. And I'll switch the view for you guys. There we go. Okay. Here's my bin of 1 million wires that I call Common wires and connections. We'll see how common it is. So this is a nice 5-position connector from a VCR. Unfortunately, that's not the kind we're looking for. We're looking for something like this. It has a couple of tabs on it, but 5-position, not 3-position. Oh, lo and behold, I have a baggie of a ton of those connectors, all 3-position. Oh, wait a second here. Oh, so close. Oh, this is from a your standard PC ATX power supply. And I thought, hey, that looks pretty close, but no, that is a 4-position. Another 4-position. Whoa. I think I have a bunch of solid core wire in here. Get rid of that for the time being. Oh. Oh. I thought this looked close to 5, but it's actually 10. Darn it. See, I know I have a lot of these connectors, but they're much too large, it looks like. Yeah. Wait. Could this be the one? Oh no, it's another 4. But it looks like almost the right size. Let's see. No, it's going to be a lot skinnier, I think. Well, this isn't much fun watching me digging through bins. So I think I might give up on the search. I don't think I have one that's small enough form factor to fit that. So we will not hook up the camera today. We'll hook up everything else, put a couple screws in the bottom of this thing, but we'll leave that the camera until another day. It's interesting that the Tightvnc on this is still displaying the last thing that it saw. So it said to press Control-Alt-Delete F, I think. So here, this was the PC that was remoted into the AtomicPi so that I don't have to use a monitor with it any longer. So let's see, Control-Alt-Delete. Oh. Well, that's weird. Or was it Control-Alt-Escape? Yeah, I guess it could solder to the board directly with this. That's not a bad idea, Pedro. No, I think I'll. Yeah, I don't want. You caught me in a dilemma because I have soldered to the board already. A couple times I soldered the power button on there. Also soldered the power connector onto there. But now I'm like, I don't want to solder any more things onto this board, and I don't want to remove it. Actually, I don't want to remove the board from where I've mounted it. So it would be easier just to find the connector and get this plugged onto it. Oops. Oh, weird. Failed to receive data from socket. Okay. Well, that's good. Let's see. Okay, yes, it does appear in the system tray. I was wondering about that. So when it, what do you call it? when it shrinks. Minimizes, that's the word. When it minimizes, yeah, it goes into the system tray. I forgot all about that. Okay. Where were we at? Yes, I think it's time to put it all together. We may have to drill a hole, like I said, into the front of the candy claw machine so that we can fit power into the front. So let's unhook everything over here. Get rid of a few things. So, gotta unplug HDMI, power. Alright, keyboard and mouse have been liberated. So here's a closer view of that connector we were talking about. The connector beside the USB, the single USB that the AtomicPi has. Now I was going to say I'm not going to give away too much, but I think I am going to give away too much. There's a board out there now that you can get that is the size of a Raspberry Pi, not an AtomicPi. That is an x86 board that has the same processor as this. It's about twice the money, but it comes with its own EEMC on board. You can get, and it has more RAM. So this board is limited to 2 gigs of RAM, 16 gigabytes onboard storage, and that's all you get. You can't expand it or anything. These new boards are an x86 board, same processor, but you can get them in 4 gig versions, what Windows 10 actually really needs. And I'm pretty excited about them. And they also have expandable EEMC, so you can get different versions all the way up to 128 gigs. So the version I would recommend for users that want to do this with their robots, have an embedded PC, I guess, an SBC in their robot, is get this new board that has just come out that has 4 gigs of RAM, 32 gigs storage. I think it's going to be a winner. I have a good feeling about it. And it is called the RockPi X. So you've probably heard of RockPi before. RockPi's been around for a while. They've produced many different little. There's actually a RockPi board that is about this big. It's crazy. It's a full-on Linux computer in the size of what we would call a toonie here in in Canada. Probably just a little bit larger than a quarter in the United States. Yeah, they've been doing these SBCs for years and have just come out with one that has an x86 Intel-based processor on it that can run Windows. And I have one. I lied, I have 2. Well, I should say, not me, but we at Tightvnc, we have 2 of them. And we'll probably be likely showing them off in the next little while after I finish this project with the AtomicPi. And I think it's pretty hopeful. It is $75 USD for the 4 gig. You know what? Let's just take a little jaunt, a little recess here, and jump over the page. There. RockPi X, now available at $75 only. So they're actually available for cheaper than that. But as you can see here, that's Seed Studios. They're selling it for, there's probably a few different versions, but as you can see, there's all RockPi this, RockPi that. A couple interesting things about this board is that it does have a full-size HDMI. I like that. Not everyone does, but I do. It has a USB-C type connector on it for power. Now, a lot of people have been switching over to that standard, so I think that some may enjoy that. And another unique thing is that they have the processor and the RAM on the bottom of the board. Very weird. But it does come with its own large heatsink that fits on the bottom. Wait a second, do I have it here? I could show you guys it. I do. Turns out that I brought it home with me. Here it is, the RockPi X. It's got one USB 3 connector, but it has 3 more USB ports, which would have been great for this project. The more USB ports, the better. Got your standard Ethernet port. It's got the standard Raspberry Pi pinout. I think it doesn't have as many accessible GPIO, and I don't even know if they're accessible actually in Windows. I don't even know how to activate them. I haven't got that far yet. I just got this board a little while ago, but since I was working on this other project, I didn't want to get distracted with this guy. Too late. So it does have an onboard USB or USB Wi-Fi antenna, but it has really low reception. So they sent a couple of these along with. Oh, actually, never mind. Just send one per board to, and these get great reception. So I'm pretty sure that's included in their package when you purchase it for $75. And I like that they have also the 3.5 millimeter audio out. I believe it has mic capabilities as well. And what else can I say about this thing? Yeah, integrated Wi-Fi, Bluetooth. Oh yeah, the EMC that we got is a 32 gigger. It's in there. You can't really see it that well, I'm sorry, but and you can't really see it in the actual diagram, but it's right here. It looks like an SD card outline like on the board, and what it really is actually it has another PCB that this is not soldered directly onto the board. There's a PCB underneath. I think this picture is maybe a different version, but a PCB fits on 2 connectors that are here and here, and it's expandable, so you can, that's how they sell the different versions, is just they plug on this other EMC module, which is a higher or lower gigabyte range of storage. And it also has a micro SD port right here. So if you do want to expand with a micro SD card, you can. I've never seen anybody use this yet, this LCD connector. So it's kind of like the CSI. No, I think they call it the DSI on the Raspberry Pi. But it does. Yeah, this board doesn't have a camera. I think a camera connector like the Raspberry Pi does. I don't know what this is. It's probably for debugging or programming. And yeah, looks like a regulator there. I believe that's the network, or might be the USB type chip or something, or a bridge chip. No idea. This is where the network chip is, the Ethernet chip. It has power over Ethernet out, which is interesting. PoE out, you can see there. And yeah, it also has a power button, which is cool. I don't know if you can see that well, but right where my finger is there is a power button to turn on and off the board. So something that the Raspberry Pi does not have, so that's pretty neat. And I'm not sure, but I think this is a fan connector here on there. Anyways, hugely distracted there. Sorry about that, but that's the size of the heatsink. It is pretty beefy, but it has to be for an Intel-based x86 processor. You always have to have really good cooling on those. So I think it'll do the trick. I don't think you'll even need a fan on this thing. It's pretty bulky and chunky. Gets the heat away from there. Okay, we'll put that aside for now. We'll continue on our quest here. Anyway, something I'm kind of excited about because it could change a lot. It's a lot more inexpensive than the Latte Panda. It doesn't have like a built-in Arduino like the Latte Panda does, which, you know, like the Raspberry Pi doesn't or anything. But you can always add one. It has lots of USB ports. Add one for about, you know, $8. Like I think this guy was. Bought a 3-pack for $24. I'd probably. if I'm saying $8, that's the right math. So what we wanted to do is check out port D12 on this guy. So let's remove him with some little bit of alcohol spray. There we go. Okay, let's inspect this, and I'll bring this camera over so you can inspect with me. And let's see how well this is going to focus in. Yeah, this is all our hot glue here. See, this is what happens when you spray alcohol onto hot glue. Amazing things happen. Hot glue just becomes immobilized. It comes right off of there. It's pretty handy. There we go. All cleaned up. Okay, let's look at D12. Just the last pin. I don't know what I was thinking, but the Arduino itself came with these headers on it. Nope, I lied. I put these headers on. So maybe I didn't solder it that great. So I'll reflow D12, make sure that's working. And let's count here how many digital I/O we have. So the first few we can't use. So we have D2 to D12. So is that 10 I/O? I think so. And then we're using 5 for the limit switches. And actually 4 for limit switches, I should say. And then 1 for, there's a photo transistor right in here. I don't know if you can see, there's a small hole there. Yeah, you can probably see that, hey? That's where the photo transistor picks up the LED, the red LED that's on this side. And so it lets you know if there's a candy that passed through the hole. Kind of gives you, my words aren't coming tonight, I'm sorry. It gives you confirmation. Confirmation, that's what I was looking for, on the candy coming through there. Alright, so let me reflow that solder joint. Oh yeah, I forgot to mention about that Rock-Pi X. It's available now. So I thought I had gotten a pre-order board, and I was way ahead of the curve. Turns out I think I got my boards, and then a couple days later they were for sale everywhere. So I didn't get to feel all that special. Okay. Get some safety glasses here. Safety first. I'll grab some flux. Good old tester. I believe this is no clean flux. Yep. So if I tell people to reflow a solder joint, this is what I mean. Put a tiny bit of flux on there, and then just stick your iron on it, and the solder should flow again. Flux makes everything flow a little nicer. Okay, that's all we really need. While I'm here, I'm just going to reflow a few other pins just in case. Okay, that's good enough. We'll leave a little solder on the tip of this iron. If you haven't done much soldering, this allows your tips to last a lot longer because it prevents them from getting too hot and oxidizing. If you always leave a little bit of solder on the tip of your soldering iron, you'll never have to use that crazy acid paste stuff that DJ uses. There's a name for it, and it escapes me. But it's some nasty stuff. It's you stick your iron in it, move it around. It's called tip tinner, I believe, but there's a chemical name for it, but I forget. Okay, so our Arduino should be G to the G's. Good to go. And I'll grab the hot glue gun, the wireless hot glue gun, and be right back. Alright, perfect. You know what, I hadn't thought about it, but if I would have soldered on the 6-pin ISP header, I'm guessing that's this header at the top of the board here, where my thumb is. I may have actually had access to several more digital I/O pins, but I forgot about that. My bad. Too late now. Okay, so I'm gonna go grab the audio amplifier and what else? What else do I need? There's a couple other things, but I don't forget. Man, it's getting late, guys. Sorry, I'm forgetting. One more USB device that's going on the inside. What is it? We got our microphone. That's included on the audio amplifier, the Arduino. Camera was going to be one. Oh, yes. Yes. The LCD. Oh, sorry, not the LCD, the VFD, I should call it. So, that's going to be our third USB port. All right, BRB. And I forgot to actually test this other guy that I have to see if it's less noisy. Let's give it a shot. So, we got yellow as the microphone port and green as the amplifier, or sorry, the audio amplifier speaker port, I guess, or a headphone jack port. So I'm gonna have to rearrange these a little bit so they fit properly. tight fit. There we go. Okay. We will have to make a spot for our microphone as well. Forgot all about that. Have an idea. Let's do this. Let us use these holes to our advantage. I was going to patch them up, but for now we will do this. Oh, darn it. I thought the audio jack could fit through there for sure. No, there's no way. We could try the microphone. No, no can do. Wait a second. This seems like it could be doable. Nope, not fitting through there either. Sad. It's just a little bit too large to fit through there. So maybe we'll just allow the microphone to hang out the side. Okay, so what we're doing here is we're going to connect up all of our stuff. Hopefully that stays. There we go. To the Arduino. Maybe I can see if I can get more light on the Arduino here. There's a little bit more light, but not too much. That'll help us see. Sorry. That'll help us see which pin is which. The silk screen on these boards isn't great, but for $8 I won't complain. You know what? I was thinking about this the other day, is that I had hot glued these headers on here and soldered them on. What I should have done is I should just create or find a PCB for cheap that these boards just plug right into, and then you can break it out into GVS, ground voltage signal pins, on each side of the Arduino. That would be pretty helpful. The thing that I love about these is that they come with the USB connector. These are the nano versions of the Arduino. Some of them will only come with an FTDI header, and I like that this is all incorporated. I don't have to worry about using an FTDI and that kind of thing. Okay, so let's get our limit switches here. So this is common. It's going to go to ground. So this rail is all ground. We have the right side limit switch, which is going to go to D2. Yeah, that's D2. Perfect. We also have this guy that needs to be plugged in. This is our VFD. And then I have a perfect spot to place it right down here. Actually, I'll sneak it under all these other wires. So because the VFD actually takes quite a bit of current, it takes about 800 milliamps, I had to, let me bring this down a little bit. I had to power the USB hub. So there, with this hub in particular, the reason why I bought it is that it actually had a micro USB jack input to power it with, right on the end of it, so I wouldn't have to like open it up and power it. So I just spliced in this micro USB cable that goes directly to the voltage input here that is 5 volts, so that works out well. We're also going to have to measure where this connector is, so we can create a hole here to plug a power jack right into there. So once we plug in all the wires, then we're going to fit this together and then throw in a couple of screws, and then we'll be on our way. Okay, let's get our leather limit switches connected. Oh man, this is going to be I thought I had tons of length, so I cut them back a bit, but look, we're a little short with these two limit switches, so I'll do those last. I'll plug them in once I get this board close, almost close to being closed up. Okay, so I'm going to undo also the photo transistor. That will go to about, I think, D7. Our remaining limit switches here. So yeah, we have 3 limit switches remaining on this side. That makes sense. We have our photo transistor. It's going to go ground and D7 or D6. D6, which, my bad. Alright, and then our servo motors, we have tons of length. That's awesome. You know what I'm going to do, just to make it easier on myself, I'm just going to grab 3 male to female connectors from my breadboard bin. Alright, we got male to female right here. We need white, green, and blue. So oh, here's another one. Okay, I'll just take from here. We'll just do purple, green, and blue. That's fine. And since we don't want these connectors to pop off at any time, we are going to tape them. Got some green electrical tape here. Alright, let's tape these guys up. I did a terrible job breaking that off, so let's just do this to make it easier on ourselves. Alright, there we go. Those should not come apart. Okay, limit switches are connected. Now let's do servos. You know what? These servo wires are much too long, so I'm going to use a twist tie to shorten that up. And okay, so let's write down a few notes here so I don't forget. We're going to go D8 is going to be we're going to go to the Synthium website for a quick second here. Go to robots. The Treat-o-matic is not near the top. So sad. We're just going to go to my profile for a quick second and go to robots. Or, no, what? I'm silly. We have it here, but that's not the robot, but the robot is here. Just need to go to the wiring diagram for a sec. Okay, so black and white is the x-axis motor. So that's going to be D8. Sorry, y-axis. Did I say X? My bad. So D8, y-axis. And that's this axis. Oh, sorry. You can't see what I'm doing there. So the y-axis is going forward and back. Okay, D9 will be the x-axis. That's this guy. It needs a twist tie. Yeah, I used to use zip ties for doing this kind of thing, but it gets kind of expensive if you're using zip ties all the time. And I found that, you know, I get a million of these twist ties from all different wires that I get. Oh, I should record the values. I think I have them somewhere, but so 77 is the center value for D8. D9 is our x-axis, and that center value is, I think it's 80 something, 87. The z-axis, which is our up and down, our claw motor, and that's 75 is the center value. Okay, and that's D10, z-axis 75. Okay, so that's all plugged in. Now we need to plug in our passive infrared sensor. And we will tuck this mic away somewhere. Okay, it's time to see if this fits together nicely or not. You know what? Actually, it's easier if I flip it upside down. I forgot about that. And you know what? I think I might be able to pass the microphone through one of these holes here. I forgot. Well, look at that. So, I only need 3 ports actually to run the servo electronics that I put on there. Oops. So what I did is I attached the motors to servo electronics that I modified to be continuous rotation. So servo electronics can do up to 4 amps on a Well, that's what the MOSFETs are rated for, probably a little bit less. So 4 amp load. So these toy motors are way less than that. So, and they're not even geared. So, well, they are geared, but you know, simple plastic gears. Excuse me. So they won't draw near like close to 4 amps to the limit. So everything will work out quite nicely. So I just need to get some screws here and bolt this down together. Seems like it's fitting in there nicely. We have a ton of room in here. Yeah, I hate small spaces too. You remember, I don't know if you saw my live hack on the submarine robot that I was creating, but man, those things were so tiny. All the parts there. So I'm just going to put in 2 screws for now. Should be enough. Keep it all together. Okay. You know what? I forgot to measure where the voltage input is, but I do have a good idea because I have a little marking here. So here we go. We will just leave the PIR sensor kind of hanging here for now. That's fine. So, alright, the next step, yes, and we have our microphone here. It's pretty long, so I'm going to twist tie that up as well. Just give me a quick second here so it's not dangling all over the place. It's funny, I hadn't really thought about this until, I don't know when it was, a few years ago. Kind of embarrassing to say, but you can make twist ties last twice as long if you cut them in half. Well, it's not that it makes them last twice as long, it's just you get twice as much out of it. So if you don't need a really long twist tie, just cut a whole bunch out of one, and you can use them on small wires like this. Okay, we'll tuck in that wiring into that corner there, and we have our microphone. Okay, next we need to get that hole drilled. So I'm going to go back to the workbench. I got a drill over there ready to go. I'm thinking, should I? Yes, I should. Let's unscrew those 2 screws that we put in. Just in case, so we get the measurements right. Doesn't take that much to take these out. I just want to make sure that everything is lined up and I don't have to drill 2 nasty holes. Okay, so that's where it's at. I'm going to measure the size that we need, and we're going to drill it in there. Okay, I'll be right back. I think I'm going to turn the lights on to make it easier on myself. So I'm going to test the size of this drill bit with the barrel of our power supply. See if I have the right size. It looks like a pretty close fit. Excellent. Alright, I'm going to give myself a nice little marker mark using a classic Sharpie. Well, it's a good thing I left my soldering iron on because I made a mistake. When I was drilling, I accidentally drilled into the connector and somehow removed a solder joint from the power connector here. Frayed a couple wires. Yep, my bad. So what I'm going to do is I'll put a little bit of electrical tape over top of that. Electrical tape fixes all. And we'll make that happen. Did you like my my tip about twist ties? Hey man, when I've been doing live hacks this long, you know, I've given you guys all of my my tips. Don't have much left. You know, a new one comes up every now and again, but I'm running low on tips these days. Okay, so that's all covered up, not exposed anymore. All right, let's solder that back on. I think I'll use my pliers to hold it. There we go. Our ground connection is back in order. So while we're here, maybe we will just plug power into it, make sure everything is good to go. Since all of our hardware is now hooked up, just want to make sure that things are operating correctly before we seal it up. Our power switch is on the off position. All right. LED over here on the Arduino's on, that's good, and I hear audio coming out of the speaker. Perfect. So the hole ended up being a little bit larger than I hoped it would because I was off a little bit. So let's hope everything works out here. Okay, I want to make sure that, you know, I'm going to use some more twist ties. Make sure this these wires are out of the way and not getting pinched when I put this thing together. Use my awesome little tip to make some more zip ties. And by zip ties, I mean twist ties. Oh man, I always get those two mixed up. Okay, I think that's good. Keep on forgetting to flip it over. That makes it so much easier when it's going together. We got white bits of plastic everywhere here. Okay, that's solid in there. whisker in there. Okay. You guys gotta let me know, is it snowing where you guys are at these days? Are you guys having a cold October as well? Our October came, our winter I should say, came way too fast. I have an apple tree in the backyard and I didn't even get a chance to take the apples off of it. There aren't many. There's only about like 30 on there, but still I would have liked to take them off before it started dumping snow like crazy. Okay, so it's all buttoned up. Let's see if our connector fits through here. Yep, it's off center a little bit, but it works. Okay. We're in, and check out our VFD is booting up too. That's excellent. Okay, so let's move a few things here. Okay, I'm gonna back up this camera a little bit if I can. I think that's as much as... Oh wait, I can do this. I forgot. Whoops. Sorry. New swing arm. I'm just getting it tightened in. Okay. There. You have a view of both the Treat-o-matic and the computer controlling it. So it should have booted into Windows by now. So this is the Tightvnc server configuration. I don't want that. And this is difficult to difficult to see, so I'm going to move this over a little bit. So oh, weird. How do you get to the actual viewer itself? Oh, weird. What if I just go like this? Yeah, that's what I want. All right, we're in. Seems like it might be still booting or something. It's on the network, but it's not displaying anything right now, unless... Interesting. So what if I turn it off and then turn it back on again? See if anything happens here. My hope is that it doesn't need a keyboard hooked up to it. I also hope it doesn't need HDMI hooked up to it. So I may have to create like this little, like an HDMI null cable, I think they call it, where you can just like hook a connector right up to the port. This is very odd. Nothing's coming up on the display. Let's try again. Oh man, blank screen. This is terrible. Gonna have to figure that out. I could put a hole in the back of this thing and just hook up HDMI to it. Do I want to do that? To see if that will work. Don't really feel like making a hole in the back of it. Yeah, just waiting around it's not coming up. So, yeah, it possibly has to have an HDMI hookup. So what I'll do is I'll pop out those two screws in the bottom. And I'll just lift up the unit a little bit and plug in HDMI in the back. Alright, let's turn this thing off. Okay, so we're going to put this on the other side. Lift up the back. Well, that was awkward and painful. let's see how this goes. The AtomicPi is on. Okay, sometimes it takes a little while to boot up. So it's still not showing up on this computer, likely because it doesn't seem to be, probably isn't on the network yet until it boots into Windows. That's very weird that it went to a green screen. It was just about to load Windows, and then it went into a green screen. Now, here's what I'm thinking. I'm thinking that we're getting into an undercurrent situation. That this power supply that I have, this guy here, oi, almost lost our whole unit there. Okay, this guy might be underpowered. So I'm going to raise this camera up a little bit. So let's replace it. And that might be the reason why we're getting this. So luckily I thought this might come down to this, so I brought a 20 amp 5 volt power supply. I just need to check to see if it's actually outputting 5 volts or higher than 5 volts. So I don't want it to produce higher. Because these guys actually, they say they're 5 volt supplies, but they're actually variable supplies. They have a potentiometer on them. Here, I'll show you what kind it is. It's I believe it's a mean well. Yeah, so they have a potentiometer in this section here that you can dial in to be, I think, all the way up to 5.9 volts and to 4.8 or something volts. So it's pretty handy to use if you're looking for something as close to 6 volts. All right, plug this in. Let us check the voltage. It actually has a green LED in here, but it's covered up. Black on the outside. Yeah, I knew it. So it's at 5.5 volts. I adjusted it at one point. So let's get into here. Darn it. I used a really tiny Robertson there. A Robertson 0. Oh man, that's in there good. Gonna upgrade to the number 2 Phillips here. Okay. Should be able to move that slightly. Yeah, the potentiometer is just down in there with the green LED. You can see it. It's a Phillips potentiometer. So let us hook up our voltmeter and adjust it to make it 5 volts. Hopefully you guys can see that. If not, I can turn the light on for you. So it goes down to, I lied, it goes all the way down to 4.2 volts. And then it goes all the way up to, I lied again, 5.8 volts. So if you liked my twist tie tip, you'll like this tip too. If you buy a 5 volt Meanwell supply, you can have it in anywhere in the range of 4.2 volts up to 5.8 volts. So there, we're about bang on 5 now. So that's pretty handy. I had no idea when I got these. I was like, yeah, 5 volt supply, that's all I need. Awesome. And then I realized that, hey, you know what? We can get a little bit more torque out of the servos if we supply them with a little bit of a higher voltage than just 5 volts. So we maxed it out, I think about 5.8, and servos like that a little better. Okay, so we are good to go with the supply. Time to plug it in and see what happens. Okay, things are booting up. I wish I could move this a little further for you guys, further out. So, no signal yet on the HDMI, and I don't know if it did it come unplugged. Let's see. Oh, there we go. Well, it's finally booting up. Sorry you can't see that. It seems to be very blurry. There we go. So we are in, and it seems to be finally attached to the network. So we'll go back over here and Control Alt, I think F. Okay, let's try to load in again. We are in. Awesome. Okay. Now let's test. Let's remove the HDMI connector and see if we can still be in. Oh, our cursor disappeared, it seemed. I can't click on stuff within this. Very odd. Okay, let's shut this down. There we go. I finally found the combination. It was Control Alt Shift F to to get out of it. So let's load that back up. Connect again. Let's see what happens. So I think that means that we require HDMI. So one last test I can do is we'll turn it off, turn it back on again without HDMI and see what happens. Okay, so we'll shut this down for now. We'll wait a few moments for that to load. Actually, I'm going to go get a drink and I'll be right back while we wait for that to load. Tonight's drink of choice, high quality H2O. Yeah, don't have much going on in the fridge today, so just gonna have some water. All right, so we are in. And it doesn't look like it is working. So we will need a solution where we have an HDMI something or other plugged into that board so we can get into it. I've never come across that before because I haven't been remoting into things. So definitely a new challenge for me. So likely this week you'll see this project jump from being about 3/4 done to getting really close to done. The hardware is almost all there. I just need to mount that, make it a little bit prettier, mount that PIR sensor, mount that microphone, build a little cable for the camera and mount the camera. So I'll do all those things this week and also start on the program since I wasn't able to get to it during the live hack. Excuse me. Sorry, let me just check here for a second. Okay, I wanted to see if there's anybody still watching. Looks like there's 3 of you guys. Awesome. So, yeah, I will be working quite a bit on this thing because I do want to have it operational for Halloween. And right now, it's almost there, but not quite. There's a few things I need to work out. I'm going to Also 3D print a little chute that comes out of, I don't know if you can see my fingers, what comes out of here, where the candy comes down, so that it will ramp out of the machine so nobody has to put their fingers in this area and, contaminate a certain area. And the idea actually that somebody had given me, I don't remember who it was actually now. I'm sorry I can't give credit where credit's due. Is that I should have it go directly into their bags. They just put their bag under where the chute comes down, and boom, candy will drop right in. So that's the idea. So I'll be creating that this week as well. So there'll be a lot of after hours work that I'll be I'll be doing to get this thing fully operational. I will likely not do any live hacking per se during the week when I'm working on this thing. I might do a little bit of filming so that I have some record myself of this thing going from what it is now till the end working unit. But I likely will do a live hack right the day before Halloween, next Friday. I think is it the 30th next Friday? I believe so. Yes, next Friday the 30th. So that'll be the finishing touches, hopefully. Or else I'll be working Halloween during the day to get this thing done. So, yeah, expect to see a jump in this thing being close to completion the next time you see me. That's the hope. That's the hope, at least. And yeah, we'll work together on some final touches so you guys can add some humor to this thing. We already have a request for a bonus mode. Maybe they get another claw of candy if they say something like, they say the classic rhyme, smell my feet, give me something good to eat sort of thing. That will activate bonus mode, and they'll get double candy. Fun stuff like that. Little features here and there that we can add. Yeah, unfortunately, I wish I could have got more into the software with you guys on these live hacks, but next week, I guess that'll be all software. So I'll be doing a little bit of hardware until that point, and then it'll be all software on Friday. That'll be it for tonight. I run into this snag, and I think I'm gonna have to fix it before we go any further. We'll have to figure out this HDMI viewing situation, and I'll have to look into building a null cable, I think they call it. So I think what happened is there's I2C on HDMI, and so this board can likely tell if there is an HDMI display hooked up to it because the I2C communication. And if the I2C communication isn't there, it just says, you know what, I'm not going to display anything. And that's what we're seeing here. It's not displaying anything. So, very odd. I don't know if that's a setting of the AtomicPi. I've not a ton of experience with the AtomicPi, so we're just learning as we go. So we'll have to see. Maybe there is a setting that I can find that says, display even though you don't have a monitor hooked up or something. We'll figure it out. One way or another, we'll figure it out. Worst comes to worst, we can just hook up a tiny display to it. We could put it on the top of the robot or something, or on the side of it. Who knows? But for now, that'll be it. I appreciate you guys joining me on this hacking adventure, and we're learning together. We're figuring stuff out, running into problems, fixing others. That's the way it goes. That's the live hack process. I wonder if one day I was thinking about this, like, how people are streaming games all the time on Twitch. Well, I searched it up, and it looks like you can actually do any sort of streaming on Twitch these days. Turns out they turned that on back in 2016, I think, where you can live stream almost any content. So I wonder if moving over to Twitch would be beneficial or not. I know if I wanted to do this more seriously, maybe I could do a little bit of like, I don't know what we call it, like fundraising on the side or something with this. I don't think live hacking isn't as glamorous as gaming is, that's for sure, and maybe not as relevant, but I would argue that it is pretty relevant in the terms of everyone getting acquainted with robotics and electronics. It's definitely helpful to have that knowledge, and it can end up giving you a career or making you money. It's pretty great knowledge to have. So it could save you money as well. Like, I myself have fixed my washing machine at home with the knowledge that I have. I've fixed my friend's dishwasher. So it can save you that kind of money. Trying to think about other things. Oh yeah, like I've fixed my own gaming consoles, iPods, phones. So these life hacks can give you that kind of knowledge, like give you some of the skills and tips and tricks that I use. I won't show you everything, like I won't show you how to open up a phone and stuff, but I can, introduce you to the tools and introduce you to the resources that you need to get there. Like iFixit is definitely a great website for fixing phones. Little tip for you. A little better tip than the the twist tie tip. Anyway, I think that's going to be it for me. Thanks a lot for joining, and we'll see you on the next live hack.